So now that we've done part A, we can start to look at part B. Part B is asking us to make a proportional controller used to control the liquid level in the third tank by adjusting the flow into the first tank. And then explain why the significance of why the importance of the sign of the proportion control parameter for different proportional gain. Kc values simulate the response of a system with 10% set point increase in the level of the third tank. At approximately what value of Kc does the system seem to oscillate? So this was our code from part 1. We will need to start by looking at, we want the set point of 3. So the set point of 3 to be equal to 1.1 times our original value of the tank, because this will now change our tank 3 set point. We'll change the height of the third tank, like this is where we want it to be. And then we have to focus on our error, which would be equal to tank 3 set point minus H3, because this will tell us how far we are from where we want to be. And then we will also need to set a Kc value, which we will make it just 1.5 for now. So with this error value and Kc, we need to just we need to make sure that since our Kc value is positive, that our error value will then become negative. This is because our Qn will be equal to our Qn times, or minus our Kc times our error. Which, if we did this correctly, there should be oscillating, which we did not. But we should see oscillating to one point within our graph. And there's something wrong, so let me figure that out. So the mistake that I made was this is plus our Kc times our error. And that is because maybe it wasn't my only issue. There's one more issue. But the plus sign is because our Kc value is positive, and then our error will end up being negative if the set point is lower than our initial value, which means that we want to make sure that we bring down our flow, and then we want it to be, if our set point is higher than our initial value, we want to bring up the flow. But let me see if I can find this other mistake. So our issue was that Qn naught was defined as Qn up here, and this was something else. So I just changed that to match what I had down here. What? This should be QN out. And then this should give us then an oscillating plot. At least I thought so. I'm missing something somewhere still. Am I backwards on the QN and QN not? I don't know what I'm missing now. Okay, so I found my mistake. I forgot to put parentheses around the 2 and the G. So now we should have an oscillating graph, but it's slowly declining as we look at it. And I believe that we wanted it to oscillate for as well as we can without declining or increasing. So we will have to change our value, our KC value each time. That's not great. We'll meet in the middle. 0.2. We're increasing. So we can do there's 0.15. So we'll take 0.15 and we'll divide by 2. Or not divide by 2. Plus. Okay. What is it? 0.175. There's a slight decline still. So we'll go to 0.85. Still a slight decline as it goes down under 28. 9. We'll try. 28.5. Now we're getting above 30. So we need to go back down. 88. .4, 29. Let's see if we can narrow it in just slightly more. 6.8. 28.4. 28.2. So maybe 7 is 8.7 is the magic number. 28.3, 28.3, 16.2, 16.1.7. So as we look at these tanks, we can start to look at that midpoint where it's oscillating back and forth, depending on the tank, to find its rough average level for each tank if we go down and find the average of all the mins and maxes here.